Alright, so hi guys. I want to apologize for the lack of uploads. I've been busy and also I got kind of sick. So, if my voice sounds kind of raspy at some point, that's why. So in this video, I want to go ahead and go over a different trig identity problem. Okay. So, give me a second. We have verify the trigonometric identity. Secant squared of negative x minus tan squared x over tan all over tan x times 2 plus 2 tan x all over the quantity 2 plus 2 cotangent x minus 2 sine squared x equals cosine squared x minus sine squared x. So, the first thing I want to do here, guys, now, obviously, one of the things that we need to understand is that you always work on the more complicated side. So that is something that we just must remember always when trying to do these. And we must make it look like the right side. That's why they're called identities. So, here, we're going to go ahead and, now this first part right here, okay, what we want to remember, guys, is that this here I'm sorry, secant, excuse me. I actually wrote it right here, sorry. Secant of negative x is secant x, so if you square both sides, you get secant squared of negative x equals secant squared x. Now, one thing I want to emphasize, guys, is that I want to go ahead and try to make this so that it is actually in terms of secant, and in terms of actually in terms of either tangent or secant. Now, and actually, give me a second. So, what I'm going to do is the following. So, I'm going to go ahead and rewrite this as secant squared of x minus tan squared x over tan x, and then of course just rewrite everything else. So this is a lot of writing, guys, I know, and I apologize. This is kind of a long problem, kind of like the last one that I did. It is difficult. So, is equal to cosine squared x minus sine squared x. Okay. Now, one thing I want to mention, guys, if you remember from the Pythagorean identities, I didn't do it this way, but now that I see it, now that I'm looking at it again, we can do it with Pythagorean identities to simplify the top. So, we have secant squared x minus tan squared x. One thing I want to do here, guys, you can either turn secant squared x into terms of tan squared x, or you can turn the tan squared x into terms of secant squared x. So we're just gonna do it by doing it in terms of replacing this. So what I want to emphasize, this here, guys, secant squared x is equal to tan squared x plus 1, I think is what it is, right? So, give me a second, hold on. So it's gonna be sine squared x over cosine squared x. Hold on, guys. Give me a second. Right, so this is one of the Pythagorean identities. Sorry, I don't know why. I almost forgot that. So what we're going to do, we're going to replace this with this right here. And you can get that tan squared x plus 1 minus tan squared x. And this is going to actually equal to 1, okay? You can do it the same way with actually doing the other way around. If I do secant squared x, and I remember that tan squared x is equal to secant squared x minus 1, because algebraically you would solve for that. And so you can do it the same way. So I'm just showing this, guys, in case y'all forgot how to do this. So it's going to be minus, and for the tan squared x, right, we can do minus and then secant squared x minus 1. So obviously, I'm just showing two different ways, guys. I know this is probably something that we either already know or we forgot, but we would then do distributive property. So we would cancel these out, and we verify that that is equal to 1. So in other words, guys, this part here, this part over here, which I'll highlight it in yellow, is going to equal to 1, okay? So we have 1 over tan x, and then times, and then it's going to be 2 plus 2 tan x over 2 plus 2 cotangent x minus 2 sine squared x equals, so we're just going to write the rest of it down. So over 2 plus 2 cotangent x minus 2 sine squared x is equal to cosine squared x minus sine squared x. Okay, so I'm just kind of, obviously we know that, again, this was equal to 1, and the bottom just stays the same. But now we're going to look at this part here. So this part here, if you remember from your reciprocal identities, that was equal to cotangent x. So sometimes you're going to have to use your reciprocal identities. If you don't, I mean, I don't think it really matters, but this is cotangent x. You could also say, and this is, which is equal to cosine x over sine x. You could also say that you're just doing the reciprocal, and you get the same thing, okay? So you still get cotangent x. So I just want to emphasize that. This is going to actually be cotangent x, right? Which is really cosine x over sine x. Okay? And again, I explained it right here. Okay? So, now we're just going to go ahead and put everything. And what I'm going to do, guys, I'm going to use my, my identities that are in terms of sine and cosine for tangent, and then as well as for cotangent. So again, we want to remember that, again, cotangent x is cosine x over sine x. So we don't, I'm just rewriting that. We obviously know that from a minute ago that we did it. So I would highlight that in purple. So really, and then tan x is sine x over cosine x, okay? So again, I'm just writing these down. So we're just going to write that down here. So it's going to go times, and it's going to be 2 plus 2. And actually, let me do this the following way because it's going to be a long expression. 2 plus 2, and then sine x over cosine x. Over cosine x. Oh my god. Hold on, guys. Okay, guys, I just rewrote it. I didn't want to waste a lot of time writing it all down. So you can just see what I did, right? I just replaced tan x with sine x over cosine x and cotangent x with cosine x over sine x. And I also replaced, obviously, the 1 over tan x with cosine x over sine x because we just did it a few minutes ago. Alright, so what's going to happen now, we're going to go ahead and actually, I'm going to keep this the same here over sine x, and then I'm going to go ahead and just rewrite the expression. What I'm going to do here, guys, actually, I'm going to go ahead, put this over 1, and what I'm going to do is I'm going to multiply cosine x on top and bottom, because that way we get that common denominator. So really, it's going to be, on the top, we're going to have 2 cosine x plus 2 sine x. And it's going to be all over cosine x, right? All over. And the same thing is going to be applied to the bottom. So we're going to put it over 1. So obviously we're going to put it over 1. And we're going to go ahead and just multiply sine x on top and bottom. So we're going to have 2 sine x. So again, this part, guys, the 2 sine x plus 2 cosine x is equivalent to 2 cosine x plus 2 sine x because of the, I think it's the commutative property. So you can rewrite it the same way as the one on the top, so you can say 2 cosine x plus 2 sine x. And then we're going to go ahead and put it over sine x, right? And then we're going to put minus 2 sine squared x is equal to cosine squared x minus sine squared x, right? I'm rewriting the right side, guys, over and over. I'm writing everything down just so y'all can see exactly how it turns into the right side. Now, what I'm gonna do, I'm gonna keep this the same. So this part is gonna be kept the same. It's gonna go cosine x over sine x. And what's gonna happen, what I'm gonna do, oh god, what I'm gonna do here, hold on, is I'm gonna go ahead and I'm gonna put it as a division of 2 fractions. So it's gonna go 2 cosine x plus 2 sine x. Actually, should just be like this. Over, it's going to be over cosine x divided by 2 cosine x plus 2 sine x. all over sine x, excuse me, and then minus 2 sine squared x, and again rewrite that right side. Some people don't rewrite the right side, they put a line. Again, everybody does it differently. I like to rewrite the right side so again we can clearly see how the left hand side equals right hand side, because sometimes it becomes very messy, so I don't want to draw an entire line, you know. But here, so now again keep this side the same. You will see how eventually how it'll turn to the other one. I'm keeping this the same because eventually I'm gonna simplify this part. So it's gonna, so this part I'm gonna simplify it. We have 2 cosine x plus 2 sine x. If you want, you can do the cross multiply thingy. How that works, it's a over b plus divided by c over d is AD over BC. So this over this, right? So we can just do that. So in reality, we have the 2 cosine x plus 2 sine x, right? And then it's going to go times the sine x, okay? So times this one here, and then over, just so we don't waste a lot of time writing everything down, over cosine x, over cosine x, so that'll be, I'll put it in green, so this part, times, and then the same thing, which it was 2 cosine x plus 2 sine x. So again, we're just doing over this part, okay? Okay, so we can clearly see, guys, that these two are going to cancel out. And then we still have the minus 2 sine squared x is equal to cosine. So then just the right side stays the same. Okay. Now, notice that these two cancel out, so then we have cosine x over cosine x over sine x times sine x over cosine x minus 2 sine squared x equals cosine squared x minus sine squared x. Again, guys, do not work on the right side. You only work on one of the sides, okay? I know that we can convert this side to this side, but don't do that. You only want to work on one side. So this becomes 1, right? And then we have a minus 2 sine squared x is equal to cosine squared x minus sine squared x. So one of the things I want y'all to remember, or that we must remember, right, is that this is going to be the Pythagorean identity, sine squared x plus cosine squared x equals 1. You could also say it as cosine squared x plus sine squared x equals 1. It doesn't matter. So you can just say cosine squared x plus sine squared x, right? So these are so Pythagorean identity, and then minus 2 sine squared x is going to equal to cosine squared x minus sine squared x. Now all you need to do is actually just combine like terms. So in reality, we know that we have these two, right? And so that just becomes cosine squared x minus sine squared x. And then that is the same thing as cosine squared x minus sine squared x. And we're done. So the left-hand side is equal to the right-hand side. And so that is how we verify this trigonometric identity. I know these are typically long, guys. I know, and I don't want to, I'm trying not to over-explain it, but at the same time, for those that are not good at trig, I want to emphasize how to do it, but I also don't want to, keep, over-explaining. But that is how we do this problem, so that is going to be it for this video, guys. If anybody has any questions, please let me know, and thank y'all so much for watching. And please like, comment, and or subscribe, and I will see you guys in the next video. Bye, guys.